Okay, here's some help with calculating density and expressing with the correct number of significant figures. A sample of copper has a mass of 44.5 grams and occupies a volume of 5.00 centimeters cubed. What is the copper's density? Express the answer with the correct number of significant figures. Density is equal to mass divided by volume. If you forget what that equation is, it is the first one on the formula sheet in your reference packet. So let's see, the mass that we have is 44.5 grams, and then we're going to divide it by 5.00 centimeters cubed. There's our mass, 44.5 grams. There's our volume, 5.00 centimeters cubed, is equal to. Then I'm going to get out my calculator. 44.5 divided by 5.00. My calculator reads 8.9, which is not enough significant figures, because the reason why it's not enough is because 1, 2, 3 here and 1, 2, 3 here. Pacific rule, you come in from the left and stop as soon as you hit a non-zero, and everything else is significant. So the 5 and the 0 and that other 0 are all significant. The rule is that when you're dividing 3 by 3, then your answer has to have 3 also. So we're going to put in a 0 here. And so 8.90 grams per centimeter cubed. Alrighty, next problem. Iron, you're told, has a density of 7.86 grams per centimeter cubed. You're told that a sample has 393 grams and asked what its volume would be. So we still start with the same basic equation, density equals mass divided by volume, but we have to rearrange it for volume. Step 1, multiply both sides so we can cancel off the volumes. And then step 2, we're going to divide both sides by density. Whatever you do to one side, you have to do to the other, so gone. So volume ends up being equal to the mass divided by the density. The mass is 390, whoops, that's not a 9, 393 grams. The density is 7.86 grams per centimeter cubed. The grams will cancel, one on top, one on the bottom. The centimeter cubed is in the denominator of the denominator, which means it will become the numerator, which is good news. That means that our unit at the end is centimeters cubed, which is perfect. We wanted to know what volume, and the unit that we're getting to come out is centimeter cubed, which is indeed is a volume unit. So we can feel confident that we've done our problem correctly. Now go to your calculator. 393 divided by 7.86 is equal to, the calculator reads out 50, but we need 3 significant figures, because 3 significant figures divided by 3 significant figures means 3 significant figures in the answer. So there you go. Last problem. This time we have the volume and we have the density, and the question is, what is the mass? Again, start with our basic equation. Density is equal to the mass divided by the volume. We're going to get mass all by itself by simply multiplying both sides by volume. That makes this go away. So mass is equal to volume times density. The volume that we were given is 40.0 centimeters cubed. And the density is 11.35 grams per centimeter cubed. The centimeter cubed is in the top and the bottom, so they will cancel. And we're left with just gram, which is good because we're calculating mass, and the unit for mass is indeed the gram. Go to our calculator. 40.0 times 11.35 is equal to 454. Three significant figures, 1, 2, 3. Why are they all significant? Because Pacific rule, you come in from the left, and as soon as you hit a non-zero, then the rest of them are significant. Three significant figures times 4 significant figures. The rule for multiplying is that the fewest number is how many should be in your answer. So fortunately, it feels comfortable because the calculator read 454, so we get to actually keep them all. So we don't even have to do any rounding of our answer to make it work out right. Okay, let's see.